Assalamualaikum. My name is Lukman from class D1AM 1102F. I represent my group to present our solution for MAT112 case study assignment, which cover two main topics: compound interest and annuity. Let's begin with question 1, which focuses on the concept of compound interest. In simple terms, compound interest is the interest calculated on both the original principal value and accumulated past interest. Unlike simple interest, compound interest causes the total interest amount to increase with each successive year. There are few key terms we use in this topic. First is the principal, which is the original amount invested or borrowed denoted by P. Next is the nominal interest rate, which represents the annual interest rate started before compounding, denoted by letter K. We also have the compounding frequency, which is the number of time interest is calculated and added to the principal per year, denoted by letter M. The final accumulated amount at the end of the investment or loan period is known as the future value or maturity value, denoted by S. To perform calculation, we determine the periodic interest rate, denoted by letter I, which is calculated as I equal K over M. Lastly, the number of interest period, denoted by letter N, represent the total compounding period throughout the entire investment duration, where N equal MT. The main formula used for this calculation are the maturity value formula, which is S equal P, open bracket, 1 plus I, close bracket, to the power of N. Alternatively, it can be written as S equal P, open bracket, 1 plus K over M, close bracket, to the power of MT. To find the actual interest earned or charged, we use the compound interest formula, which is I equal S minus P. Moving on to question 2A, we are given a principal value of Rm 28,007 ringgit and 25 cents and a final maturity value of 42,449 ringgit and 65 cents. The nominal interest rate is 6% compounded every 4 months, which means the interest compounded 3 times a year, giving us a compounding frequency of 3 and a periodic interest rate of 0.02. To find the duration in year, we substitute this value directly into the maturity value formula. By dividing the maturity value by the principal, we get 1.02 to the power of 3t equal 1.51563. Next, we apply common logarithm on both sides of the equation, which simplify to 3t log 1.02 equal log 1.51563. To solve for 3t, we divide log 1.51563 by log 1.02, which gives us 21. Finally, dividing 21 by 3 gives us our final duration of exactly 7 years. To find the total amount of interest charged, we subtract the principal from the maturity value, which result in total interest amount of 14,442 ringgit and 40 cents.
So for the questions to B, the question states that ISMA invested RM 50,000 in a financial scheme that pays 5% interest compounded every month. First, we identify the given information. B is RM 50,000. The interest rate R is 5%, which is 0.05, and it is compounded every month, so there is 6 compounding periods per year. So the times T is 4 years. We use the compound interest formula, which is S equals to P, open a brackets, 1 plus R, divided by N, close the brackets, power empty. Substituting the values into the formula. So, S equals to 50,000, open a brackets, 1 plus 0.05, divided by 6, close a brackets, power by 24. So the answer is S equals to RM 61,019.35. Therefore, the accumulated amount in the account today is 61,019.35 ringgit. Next, for part 2, ISMA adds another RM 12,000 to the account today. So the new principal becomes P equals to RM 61,019.35 plus RM 12,000 ringgit. So the new P becomes RM 73,019.35. The investment then continues for 3 years and 8 months. We convert the time into years, so it will become 3.6667 years. So, since the interest is compounded 6 times per year, so MT is equals to 6, open a bracket, 3.6667, close a bracket, equals to 22. Using the same compound interest formula, so S equals to 73,000, 019.35, open a brackets, 1 plus 0.05, divided by 6, close a brackets, power 22. So S equals to RM 87,629 ringgit 53 cents. Therefore, the total amount after 3 years and 8 months is RM 87,629 ringgit and 53 cents.
First, let's look at the concept of an annuity. By definition, an annuity is a series of equal payments made at equal interval of time. Unlike a standard compound interest scenario, which only involves a single lump sum deposit growing over time, an annuity focuses on continuous and recurring cash flow. We see annuities everywhere in daily life. For instance, deposits such as making regular monthly saving into a retirement fund. We also see them in payments, such as paying off your monthly car loan or house mortgage. Moving on, to analyze or solve any annuity problem, we must be familiar with these 4 fundamental key terms and symbols. R stands for periodic payment, which is the fixed amount of money paid or deposit each period. T presents of term of annuity, meaning the total duration of the loan or investment impressed in years. M is the compounding frequency per year, which tells us how many times interest is calculated annually. And K stands for nominal annual interest rate given by the financial institution. Finally, let's look at the ordinary annuity formula. In the course, we focus on ordinary annuities, where payments are strictly made at the end of each payment interval. Depending on what problem asked, we use 2 primary formulas. The first one is the future value of an ordinary annuity. We use this formula when we want to calculate the total accumulated wealth of our saving at the end of the investment term. The second one is the present value of an ordinary annuity. This is used to determine the total loan amount borrowed or the value of an asset at the very beginning of the term today. Now, let's move on to question 4a. This question requires us to find the regular monthly withdrawal amount denoted as AX from a funded account over a period of 11 years. First, let's look at the extracted information from the problem statement. Our present value A is Rm 26,519 ringgit and 59 cents, which is the initial lump sum deposit. The nominal annual interest rate, K, is 4% or 0.04. The compounding frequency, M, is 12 because the interest is compounded monthly. The term T is 11 years and the periodic payment R is what we need to find, which is assigned as X. From these values, we calculate our periodic rate I by dividing K by M, giving us 0.04 per 12. We also find the total period N by multiplying M by T, which gives us a total of 132 monthly intervals. Next, we move to formula substitution. Since this is a regular withdrawal from a funded account, we use the present value of an ordinary annuity formula, as shown right here. Substituting our extracted values into the formula gives us. For the mathematical solving phase, we carefully calculate the entire expression inside the large bracket using our calculator. This simplifies the equation to isolate X, we divide 26,519 ringgit and 59 by 106.647648, which gives us a raw calculation value of 248.66954,933. Finally, we round this number to two decimal places for currency, bringing us to our final answer. Therefore, Sharif can successfully withdraw Rm 248 ringgit and 67 cents at the end of each month for 11 years before the account is fully depleted. Thank you.
For question B, number 1, using the present value annuity formula, we substitute the monthly payment of Rm 987.16, monthly interest rate of 6.5% divided by 12, and 300 monthly payments. The calculated annuity factor is 187.8989, and multiplying it by Rm 987.16 gives Rm 146,000. Therefore, the loan amount is Rm 146,000. For B2, to find the total interest paid, I first calculated the total number of payments by multiplying 25 years by 12 months, which gives 300 payments. Then I multiplied the monthly payment of 987.16 by 300 to get the total amount paid, which is Rm 296,148. Finally, I subtracted the original loan amount of Rm 146,000 from the total amount paid. Therefore, the total interest paid over the 25-year loan period is Rm 150,148. For B3, to find the amount needed to settle the loan immediately after the 250 payment, I calculate the outstanding balance by finding the present value of the remaining 50 monthly payments. Using the annuity formula, we substitute the monthly payment R equals to Rm 987.16, the monthly interest rate I equals to 0.0054167, and the remaining number of payments N equals to 50. After substituting these values into the formula, I obtain an annuity factor of 43.761. Multiplying this factor by the monthly payment gives Rm 43,198.80 cents. Therefore, after making the 250 payment, he must pay an additional Rm 43,198.81 to fully settle the loan.